We're going to go ahead and take a look at number 99 from section 2.1, the rectangular coordinate system. Number 99 is entitled Demand Equations. What I would suggest that you do is please pause the video and make sure that you have your textbook out in front of you. Also make sure that you have something to write with and something to write on so that you can jot down important information from the narrative. So here goes. Number 99. The number of photo scanners that consumers buy depends on price. The higher the price, the fewer photo scanners people will buy. Kind of makes sense. The equation that relates price to the number of photo scanners sold at that price is called a demand equation. If the demand equation for a photo scanner is P is equal to negative 1/10 times Q plus 170, where P is going to be price and Q is going to be the number of scanners sold at that price, how many photo scanners will be sold at a price of $150? Okay, so again, to kind of pick apart the problem to maybe understand it a little bit better, notice that this is kind of written in a slope-intercept form, only instead of x and y, the author has decided to use p and q. Okay, so the 170, this is in your y-intercept position, and this is actually how much the scanner is if no scanners are sold. Okay, if you kind of think about it, if you put 0 in for your q variable, negative 1/10 times 0 plus the 170 will just simplify down to 170. So P, your price, will be equal to $170. Basically, what we are saying here then, in terms of our growth rate, we're saying that every time we want one scanner to sell, we need to knock the price down by 1/10 from that 170 price tag. Okay, so to sell a certain number of scanners, we need to take the price down, hence the negative, by 1/10 of the initial $170 price tag. Okay, it's kind of a lot to wrap your head around, especially since the problem doesn't really discuss it terribly in a lot of detail. But there's a little bit more background, so hopefully that'll kind of remove some of the fog. Our main concern is that we want to say how many photo scanners will be sold at a price of $150. Well, they're asking us how many photo scanners, so that means that we need to figure out what the variable Q will be equal to. But we know that in this case, we want the price, or we're curious to know how many scanners would be sold if we were to knock the price down to 150. So that means that we would plug 150 in for our variable P. And notice now, by plugging that in, we only have one variable to solve for, which is ideal. It's pretty easy to solve an equation where only one variable is left unknown. So we'll subtract 170 from both sides. So those will clear out. This gives me negative 20 is equal to negative 1/10 times Q. And what we can do here is, let's go ahead and multiply both sides by a negative 10. Because this will get rid of the negatives between the two, and it will also cancel out the 10 in the numerator and denominator. And this tells me that if I were to knock the price down to $150, that's going to mean that I will sell 200 scanners. Okay, and again, we want to include that context. So there you have it. If you have any questions, please feel free to stop by. I'd be more than happy to sit down and look at these problems in a little bit more depth with you.